Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to take up a new topic in the series carboxylic acid derivatives only, and that very new topic is acid chloride. So before jumping to this one topic, I would like to request you to go through the previous 3 videos that I have uploaded in this particular series, and the link that I have mentioned in the description box only. So go over there, check that wisely, and then come to this part of the video so as to get a better understanding of the topic. Okay, so proceeding further. Okay, so first of all, see this chart over here. Okay, this is the topic we are going to discuss firstly, but before that, let's see this chart over here. Okay, all right, so this is the chart. Correct. Over here you can see the four acid derivatives. First one is your acyl chloride being more reactive, then comes anhydride, then comes ester and amide. All of these derivatives you can see on hydrolysis, they are giving back your parent carboxylic acid. Correct. So acid chloride is more reactive and amide over here is least reactive. That we have discussed in the topic relative order of stability of your acid derivatives in second video that I have uploaded in this particular series. So yeah, a link is mentioned over here in the description box. First go over there, then come to this part. Only then you will be eventually getting a proper understanding of this topic. Okay, so the very first topic that we are going to see in this particular series is your interconversion of acid derivatives by nucleophilic acyl substitution. See what is happening due to large difference in the reactivity of all of your acid derivatives toward nucleophilic acyl substitution. What is happening? It is quite possible to convert a more reactive derivative into least reactive derivative. अंडरस्टैंडिंग बस एक चीज अपने दिमाग में रखिए कि आप क्या कर सकते हो, क्योंकि आपके रिएक्टिविटी का डिफरेंस बहुत ज्यादा है और ज्यादा डिफरेंस होने की वजह से क्या होगा, जो ज्यादा रिएक्टिव एसिड डेरिवेटिव होगा इट कैन गेट कन्वर्टेड टू द लीस्ट रिएक्टिव एसिड डेरिवेटिव. Okay, for example, your acid chloride is getting converted to the anhydride, esters and amide. Okay, while your anhydride being least reactive as compared to acid chloride, it will not give back acid chloride, but it is actually being more reactive than esters and amide, so it get converted into esters and amide. Understanding? Getting my point? So that is one thing. Also your ester is least reactive as compared to acid chloride and anhydride, so it is not going to give back these two acid derivatives, but it can possibly get reduced to amides because ester is more reactive and amide is least reactive. Quite understanding, right? So proceeding further to the main topic, acid chloride. See, acid chloride or halide, they commonly are called as the derivative of your carboxylic acid, where your OH group is getting reduced or replaced by, not reduced, sorry, it is actually getting replaced by your X atom. X could be anything: chlorine, bromine, fluorine and iodide. Okay, getting that? So which is why you can name it as acid chloride, bromide and iodide accordingly this. Okay, so this is the structure of your acyl chloride. Getting that? This is how you represent your structure of acid chloride. See it properly. Okay, alright, so let's proceed to the next topic, that is nomenclature of acid chloride. See what is happening over here. You can see the first acid, that is your HCOOH. What is the name of this acid? It is your formic acid. Okay. Okay. Now see what they are saying. The name of the acid chloride, they are obtained by replacing the terminal IC acid, that is your terminal IC acid, by, if your this carboxylic acid is getting converted to this derivative. Okay. Now what is the name of this very derivative? You have to replace this IC acid with YL chloride. So what is the name? It is going to be formyl chloride. Understanding? And its IUPAC name would be methanoyl chloride. Understandable? Getting that? See, like that. So the common name of this very structure is formyl chloride and IUPAC name is methanoyl chloride. Getting that? Okay, because it is carrying one carbon. Okay, over here it is carrying two carbons, so its IUPAC name will be ethynyl chloride, and the common name is going to be acetyl chloride. Likewise, you can see the rest of the two examples as well. So we have some other examples in your nomenclature of acid chloride, and the rule will remain same. How you are going to name it, that I have already told you. You will replace the terminal IC acid with suffix YL chloride. Getting that? So this is your first example. You can see over here. You have to start the numbering from your functional group derivative. Okay. So this is how we'll start with it. 1, 2, 3 and 4. Okay. So you can see on second and third position we have methyl group attached. So you can write it as 2,3 dimethyl, because we have two methyl groups present over here. So dimethyl. Okay. This is how many carbon atoms are present? 1, 2, 3, 4. 4. So for 4 we use but. Correct. So 2,3-dimethyl butane oil chloride. Correct? This is how you do it. Now, see the second example over here. See, you can see over here the second example. Okay, let me just change the color of the pen. Okay. So this cyclic structure, this ring structure, you can see that is your cyclohexane. Okay. So that is how you have written the name cyclohexane as such. Okay. And this is your carbonyl group attached. So you can write this as cyclohexanyl carbonyl chloride. That is quite simple nomenclature for this very compound. Okay. So likewise, you can see the rest of the example as well. This is the basic rule that I've already told you. Terminal IC acid should be replaced with suffix YL chloride. Okay. Everywhere you can see that is how they have done. So that is the basic nomenclature of your acid chloride. Quite easy, right? So proceeding further to the preparation of acid chloride. See, there are two methods that we are going to see for the preparation of your acid chloride. The first one being from carboxylic acids. Second one is from carboxylic acid salt. So we'll take each one step by step. The first one is going to be from carboxylic acid. See what is happening. Acid chloride, they are easily prepared from the corresponding acids by reaction with either phosphorus pentachloride, phosphorus trichloride and thionyl chloride. See about that, I have already discussed this kind of reaction in the carboxylic acid chapter. So you can see the video from that particular section. Over there I have also discussed its mechanism as well. Okay. So for better understanding, you can check that particular video in carboxylic acid. I am repeating, not in derivative part. In carboxylic acid, I made a separate playlist for the same in my channel. So you can check that from there. Okay. Alright. So these are the possible reaction for the preparation of acid chloride via your carboxylic acid. You can use thionyl chloride. Okay, and you can use phosphorus pentachloride and phosphorus trichloride. And yes, over here I would like to mention this particular method is more feasible. Okay, more actually useful, and they widely use this particular method only, and its related mechanism, as I've told you, we have discussed in the chapter carboxylic acid. Okay, so reason being that these gases will get being more volatile and it will get evaporated off. So ultimately you will be left with this original product, pure this product in your pure form, you can say. Okay, so you will be getting your acid chloride in your pure form. Okay. So proceeding further. Okay, this is the example of same where your ethanoic acid on treatment with phosphorus pentachloride is resulting in the formation of ethynyl chloride, and POCl3 and HCl is reduced as a side product as well. Okay, then your phenylacetic acid, 3 moles of it is reacted with phosphorus dichloride, resulting in the formation of 3 moles of phenyl acetyl chloride, and H3PO3 is also released. Okay, then comes your benzoic acid on reaction with thionyl chloride. This reaction is always going to be more feasible, as it is going to give you your acid chloride in your pure product. Okay, this your pure acid chloride. Okay, because these two gases being volatile, it will get evaporated off. So there are no side products left. Okay, clear? So we'll discuss another method of preparation, that is from carboxylic acid salts. So your acid chloride, they can also be prepared by distilling sodium or calcium salts of carboxylic acid with phosphorus trichloride, sulfuryl chloride and phosphorus oxychloride. Okay. So these are the example of the same, where your sodium ethanoate, that is the carboxylic acid salt. Okay, reacting with PCl3 and distillation, it is resulting in the formation of this ethanol chloride and Na3PO3. Similarly, you can see the rest of the two reaction as well. Okay, so that's all in the preparation of your acid chloride. Okay, and now what we are going to discuss over here is the physical properties of acid chlorides. Okay, so basically there are three physical properties of your acid chloride. First that we are going to take up is your physical state and smell. Okay, so your lower acid chlorides, for example, if we talk about this only, your formyl chloride, they are actually colorless, low boiling liquids. Any of your lower acid chlorides, they are going to be colorless, low boiling liquids, while the higher members are going to be colorless, low melting solid with pungent and irritating odors. Okay, and these higher members, they fume in air due to the formation of HCl by hydrolysis. Understanding? So this is all about your physical state and smell. Let me repeat it for you. What we have discussed, that जो आपके lower acid chloride हैं वो आपके colorless होंगे, low boiling liquids होंगे, वहीं आपके जो higher members होंगे, they are going to be colorless, low melting solids, okay, with pungent and irritating odor that fume in air due to the formation of HCl by hydrolysis. Okay, that is about physical state and smell. Then comes solubility. Solubility में अगर हम बात करें, आपके जो acid chloride हैं, they are most soluble, readily soluble in all or you can say most of the common organic solvents such as ether, benzene, chloroform. Okay, you have to keep this in your mind that जो आपके acid chloride हैं, they are soluble in ether, benzene and chloroform. These all are organic solvents. Then comes your boiling point. That the boiling point of your acid chloride, they are lower than those of parent acid. So if you are talking about HCOOH, if for example they have given you HCOOH and HCOCl and they have asked the boiling point, which of them is going to have the higher boiling point. So you should keep this in mind that your parent acid is going to have more boiling point as compared to acid chloride in spite of their greater molecular masses. Why? Because unlike carboxylic acid, acid chloride do not resulting in the formation of your intermolecular hydrogen bonding. Okay, so this is the reason your acid is having more boiling point as compared to your acid chloride. So a question can come over here, why your parent acids are having more boiling point as compared to the acid chloride. So the answer, you know that your acid chloride do not form intermolecular hydrogen bonding, so which is why it is having lesser boiling point as compared to your parent carboxylic acid. An example has also been given. Your ethanoic acid boils at 391 Kelvin while ethanol chloride boils at 324. Similarly, we have one more example, that is benzoic acid boils at 523 Kelvin and benzol chloride boils at 470 Kelvin. Correct? Alright, so I will stop my video here only. So far we have discussed the interconversion of your acid derivatives into higher acid derivatives and higher reactive acid derivative into least reactive acid derivatives. And we have discussed the nomenclature of acid chloride, its preparations, methods, its physical properties we have discussed. So in the next video we are going to discuss the chemical properties of acid chlorides, and yeah, that's all about this particular topic. So if you have not understood anything in this particular topic, just mention your queries in the comment section and I'll take it as soon as possible. Okay, so yeah, that's all about it. Like, subscribe my channel and press the bell icon for more updates for the videos that I upload on daily basis. And yeah, keep showering your love. Thank you.